Hey guys, today we're going to be taking a look at 4.3, which is going to be solving rational equations. Now, there's two different ways that rational equations can look. One is you could just have a fraction is equal to another fraction. That's also called a proportion. Now, to solve a proportion, you just need to cross multiply. Okay, so we're going to solve each of these proportions by cross multiplying. There's a property that says if you have two fractions that are equal to each other, their cross products will also be equal. So you can multiply diagonally. Now, I'm going to multiply this numerator times that denominator. The final answer can either go on the left or go on the right. That doesn't matter how you write that. Okay, but I'm going to multiply these two. That's going to give me 4x plus 16 equals, and then I'm going to multiply these two. That's going to give me 8x minus 32. And now I have an equation that doesn't have any fractions. Okay, and that's kind of what I want. This is just an Algebra 1 problem. I'm going to get my x's together. I'm going to move the 32 to the other side by adding 32. And then I can divide both sides by 4 and get 12 equals x, or x equals 12, and that is my solution. If you plug this in, okay, if you check your answer, you're going to get 12 minus 4 divided by 4 is equal to 12 plus 4 divided by 8, and 12 divided by 8 is 8, 8 divided by 4 is 2, 12 plus 4 is 16, 16 divided by 8 is 2, and so the two sides do equal each other, okay? Take a look at the second one. Very similar. We're going to cross multiply, so if I multiply these two, I'm going to get 5x plus 5. If I multiply these, I'm going to get 3x squared plus 3x. Now, what's different about this is after I cross multiplied, I ended up with a quadratic. So, to solve a quadratic, we're going to move everything to one side, the side that's got the quadratic on it. So, 0 equals 3x squared. I'm going to subtract the 5x from the 3x, that's minus 2x. I'm going to subtract the 5 to the other side, that's minus 5. And now, hopefully this will factor 3x and x, and then I need factors of negative 5 strategically placed so I get a negative 2. So I want the negative 5 and the plus 1 to be like that. I need the 5 and the 3 not to multiply each other. That'd give me a 15. So I need them in the same set of parentheses. That's a 3x, that's a negative 5x, and that would give me my negative 2x. So my answers are positive 5/3 and negative 1. Now, if you're going to check that, the negative 1 checks pretty easily. The 5/3, that'd be a little bit more work to try to put a 5/3 in for that x and a 5/3 in for that x, but it does work, okay? Now, next one, again, cross multiply. 4x minus 4. But the other direction, this is a binomial times a binomial, so I need to FOIL that out. So x squared, let's see, it's going to be minus x plus 3x, so that's plus 2x, and then minus 3. So again, I have a quadratic. I need to move everything to one side. X squared. Let's see, I have a 2x. If I subtract 4x, I'm going to get minus 2x. And then if I add 4 to the other side, I'm going to get a plus 1. x minus 1. So x equals 1. Okay? Now, if you check that, we're going to have an issue. If you put a 1, which just solved the equation we just came up with, if you plug a 1 in, you're going to get a 0 in the denominator. Okay? 1 is one of those restricted values that x is not allowed to equal. So there are times where you're going to get what's called an extraneous solution. It's a solution that works mathematically as far as the algebra is concerned, but if you go to plug it back in, it doesn't work. So if there were two answers and one of them didn't work, then the other one would be our answer. But in this case, there are no solutions to this problem. Okay? So that's an extraneous solution. Now, the bottom, this is where it gets more interesting, because these examples are not proportions. This is a fraction plus a fraction equals another fraction. And how we're going to solve this is similar to when we were adding and subtracting. We're going to look at our denominators, okay, and we're going to think about what our common denominator would be. This is an x plus 2. If you factor this, this is an x times an x plus 2. So that actually is the common denominator between all these. Now, I do not want to go through the trouble of creating common denominators and trying to solve that. What's a much easier way to do this is to just get all your denominators to just disappear on you. If I multiply everything, and I mean everything, both sides, that fraction, and that fraction, by this common denominator, one at a time, what's going to happen is, if I take this expression times the 5 over x, that x is in the numerator, that x is in the denominator, so they will cancel. I will not have a fraction anymore. Now, I still have a 5 that's multiplying this x plus 2, so that's 5x plus 10. Don't forget to distribute. And then that's it. Plus, and then we're going to go to the second fraction. That x plus 2 and that x plus 2, because we're multiplying, those are going to cancel. So once they cancel, I'm still going to have the 3, I'm still going to have the x, so that's a 3x. But again, there's no fractions anymore. Equals, this is that. When I multiply these, what I'm really doing, I know I'm not writing it this way, I'm multiplying both sides by that same value, okay, that same x plus 2. And as long as you do everything to both sides, it's fair, okay? So when these multiply, this is going to completely cancel with that, and it's going to leave me with a negative 6. That's it. This is the algebra problem that you now have to do where there's no fractions anymore. So this is an algebra 1 problem. This, what we started with, that is definitely not an algebra 1 problem, okay? So this is 8x plus 10 equals negative 6. If I move the 10 over, 8x equals negative 16. If I divide by 2, I get negative 2 as an answer. That would be one of my restricted values, negative 2. So that does not work, and there are no solutions. All right. Let's look at the next one. So again, it's all about factoring. We want to see what our denominators are. That's an x minus 3. That's easy. This one is x, let's see, plus 3, and then an x minus 1. And then I've got this 1 over here. All right, so this is my common denominator. If I multiply everything through by this x plus 3, x minus 1, one at a time, it'll cancel out my denominators for me. So, first fraction, the x plus 3's cancel. Now, I still have an x plus 2 times this x minus 1, so I do need to multiply those together. So that's going to be x squared. It's going to be a minus x and a plus 2x, so that's plus x. And then the 2 and the minus 1 is minus 2. All right. Then I'm going to multiply this times the second fraction. But that is that denominator. They completely cancel, and I'm just going to have a 1 there. That's it. Equals. Now, this side, there is no canceling. Okay, so this entire expression is going to multiply that 1. Now, remember what this was. This was this denominator. So if I want to go ahead and FOIL that back out, it's just going to look exactly like that. So x squared plus 2x minus 3. All right, so now I have to solve this. Now, it is a quadratic, which typically means we're going to move everything to one side. But if you look at it, I've got an x squared over here and an x squared over here. If I try to move either one of these, they're going to cancel. So now I just have x, well, minus 2 plus 1. That's minus 1. And then over here, I have 2x minus 3. So I can move these x's over here. That's going to be an x. I can add these 3 over to here. That's 2. and I'm going to get x equals 2. Now, going back and looking at my original denominators, negative 3 was restricted and positive 1 was restricted. So that answer is fine. Okay? All right. Next one. I've got a 5. I've got nothing. I've got a 1 here. That's just a 1. And then I've got this 5x minus 25, which is actually 5, and then x minus 5. All right, so this is my common denominator. That has a 5, but this also has this extra x minus 5. So I need to multiply everything by 5x minus 5. So the 5's will cancel. That'll leave me with 4 times x minus 5. That's 4x minus 20. Plus, then I need to multiply this, but there's nothing going to cancel here. So that x is going to multiply all of this. Now remember what this is. This is 5x minus 25 just in factored form. So I need to multiply x times 5x minus 25. So that's 5x squared minus 25x equals. And then on the other side, when I multiply this, that 5 and x minus 5 is going to completely cancel with that 5x minus 25. Okay, so that'll just leave me with 4x minus 50. And now it's just a matter of algebra from here. I've got my x squared over here. I'm going to get my x's together. I've got a 4x. Oh, that 4x and that 4x are actually going to cancel each other. So that's negative 25x. And then I've got a minus 20. I need to bring this minus 50 over, so that should be plus 30. Okay, do not try to factor this into 2 sets of parentheses. Factor your 5 out first. And that will be much easier. So factors of 6 that add up to negative 5 are going to be minus 3 and minus 2. So x equals 3 and 2. And if I go back, this one actually has 2 solutions. Neither one of those are going to be like extraneous solutions. All right, I need you to try this last one. Again, this is for x plus 3. This is also for x plus 3. And then that's a 4 and that's a 4. So I need you to multiply everything by 4x plus 3. Pause the video, and then when you get done, unpause it and see how you did. All right, so you had to multiply everything by 4x plus 3. So the first one, everything canceled and just left you with a 5. The second one, the 4's would cancel, but you still had to multiply the negative 3 times this x plus 3. So check, did you get a minus 9 right there? Did you distribute the negative as well? That's usually the trick on this one, okay? On the other side, again, that 4x plus 3 is going to cancel that 4x plus 12 completely, leaving us with another 5. And then again, the 4's cancel, but then that minus x needs to multiply all of this. So you're going to get a negative x squared and a minus 3x. Now, if you got that all right, you're going to notice that these two 5's are going to cancel each other. I've got this negative 3x and this other minus 3x that are going to cancel. And so I went ahead and moved my quadratic to the left because I wanted it to be positive, and I was left with x squared minus 9, which factors into x plus 3 and x minus 3. So I get 2 solutions, but the negative 3 doesn't work. Okay, that would be one of my restricted values. So for this one, just the positive 3 is the correct answer. Okay, so take a look at your worksheet. Let me know if you got any questions.